Hi, everyone. Imagine taking an ice cream out of the freezer, leaving it for an hour, and then putting it back in the freezer again. Yeah, you probably could freeze it again, but it won't look or taste the same. This is kind of similar to the irreversible harm that climate change causes our environment, melting the polar ice caps, for instance, or causing the extreme weather conditions that get worse every year. And a major contributor to this climate change are greenhouse gas emissions, and certainly carbon dioxide emissions, which have their levels rising in the atmosphere every year. So how can we deal with these growing emissions? Well, there is the ongoing clean energy transition. However, I believe that in parallel, we need to develop CO2 capture systems. So CO2 capture happens by trapping the gas within a solid or a liquid. In my research, we looked at nature and saw that a naturally occurring phenomena explains a lot about my project. So this here is the diving bell spider. It is able to capture an air bubble underwater and use this air bubble to survive under the water for over 24 hours. So how does it do this? Well, it has a combination of two elements, surface texture and surface chemistry. So surface texture comes from the microscopic pin-like structures that it has on its back, whereas surface chemistry comes from the waxy water-repellent coating that it has over these textures. In my work, I was able to design surfaces that behave similarly to capture CO2 bubbles. For surface texture, I created repeating pyramids on silicon using a laser beam. Whereas for surface chemistry, I deposited a water-repellent coating over the textured silicon using vapor deposition methods. This resulted in a surface that is able to trap gas bubbles under a liquid, therefore mimicking the behavior of the diving bell spider. So what makes these gas capturing surfaces potentially game-changing? Well, two main challenges with CO2 capture on an industrial scale are energy requirements and costs. Because these surfaces are able to capture CO2 more spontaneously, this means both challenges can be addressed. This in turn means that the technology can become more usable, and therefore we can get closer to our net zero emission targets. Finally, going back to how destructive climate change has been, we can draw inspiration from nature as it gives us such hints and asks for help. Thank you.